All right, so this tutorial is going to walk through everything that you need in order to create a very basic Hello World application on the Ethereum blockchain. It won't go through actually deploying it to the Ethereum blockchain, but we will use Ganache, a local blockchain, to test on. So the end result is going to be something very basic that looks like this. We have our Hello World. We can change world to whatever we want. In this case, we'll change it to human. When we click submit, you'll see it integrates in with MetaMask, tells you what your gas fee is going to be, and then you can confirm the transaction and you have submitted a change to your local blockchain. It refreshes and now you can see it says, hello human. So in order to get started, we're going to need a few things. The first thing that we're going to need is we're going to make sure that we have Node installed. If you don't have it already, probably the easiest way is just to go to nodejs.org, follow the instructions for installation. There's a bunch of different ways to do this. I find this to be one of the easiest and most consistently successful ways of doing this. If you think that you might have Node installed, you can check by typing node-v. If it comes back with a version, that means you have Node installed. The other thing that you will need is npm. That's Node Package Manager. Again, throw a -v on there, and that will show you that's installed. These are the versions I'm currently using, so if you have any issues with something not working and your versions are different, maybe that's it. Just something to keep in mind. We're also going to need the Truffle suite. Truffle is a testing framework for Solidity contracts. So Solidity is the language that we will be using to create a smart contract on the Ethereum blockchain. And Truffle is kind of a test suite that enables us to, one, do test-driven development, and two, migrate and deploy our contracts to our local version of the blockchain. Truffle installs via npm, so you can just npm install it. The G means that you'll install it everywhere. To check if you have Truffle installed, you can run Truffle version, and that'll tell you that you have it installed. Again, these are the versions I'm using. Take note if yours are different, if things don't work. On top of Truffle, there's a lot to install before we get going. So we have Truffle installed, we have Node. We're going to need Ganache. Ganache is a blockchain for local development. It'll basically give you a test environment that you can run locally that acts just like a full blockchain without having to deal with all the setup. It's great because you download it, you don't have to worry about syncing with an actual blockchain, anything like that. And so you can do all your development work locally. You'll need to download this and install it. Once it is installed, it should look something like this, but probably you won't see any of these actual addresses yet or anything like that. It'll ask you for a new workspace. It'll be this window right here like this, and we'll be using a new workspace here shortly. On top of that, we're going to need MetaMask installed. MetaMask is a wallet that will enable us to interact with our application. It's a plugin. I know it works really well with Firefox and Chrome. I will say the Chrome version does not support hardware wallets currently, or at least the ledger that I have. So that's something to keep in mind as well if you are interested in using a hardware wallet. For these purposes, we're going to be using the wallet that Ganache creates, and that will make it really easy. We don't need to worry about sharing our secret seed phrases or anything like that because they're not real. So we'll need to download and install MetaMask. You can see I have it installed right here. Looks something like this. Yours may look more like this with the awesome fox that follows your mouse around. We'll be using our secret recovery phase here shortly once we get going. Finally, we will be using Svelte. So we'll be doing this in a little bit, as well as Svelte Web 3. It's an npm module that will enable us to connect to our wallet and the blockchain using Svelte. This is awesome stuff. You'll see how slick and easy it is once we get there. So, long story short, we've got a bunch of stuff to install. Once you get all this installed, you're ready to go. The first thing that we'll need to do is we'll need to create the actual contract. So this application talks to a contract on the Ethereum blockchain. Contracts are basically contracts, you can think of them as a set of functions that are kind of wrapped up inside of a container known as a contract. They're basically little modules that you can actually deploy to the blockchain and interact with. The first thing that we're going to do is create a directory for all of our work to live in. I went ahead and just set up one, called it Solidity Svelte. I know, it's an amazing name. And then from there, we will need to initialize the truffle config. So the best way to do that is with truffle init. That'll take your current directory and it basically creates a scaffold for your truffle project. It's created a contracts directory, a migrations directory. Migration is truffle for deployment, a test directory, and then a truffle config. That basically tells truffle what to do. You can think of truffle config very similar to package.json. It basically tells truffle what versions of things to use, where to put stuff once it actually does compile the contracts and everything like that. All right, so the next thing that we'll need to do is we'll need to create a contract, right? And it kind of gives you an example up here that scaffolds out what we're going to be doing. So I'm going to keep it really simple. We're doing hello world. I'm going to call our contract hello. So it's truffle create contract hello. Cool. It doesn't tell us that anything actually happened, but if we look in the contracts directory, you'll see now there is a hello.sol. The SOL stands for Solidity. I will say one thing that's very confusing. There's a great new blockchain out there called Solana, and the token for that is Sol, but Solidity also uses that as a file extension. So we've created our contract. We also need to create a test, right? Because test-driven development is a great way to learn. So we'll truffle create test, and we'll call it hello test. Again, it looks right now like we're just creating files, but it's actually putting a little bit of information in there, which is really helpful and really nice. If we look in the test directory, you can see there's a new file in there. So let's fire up VS Code and take a look at this directory. All right, so we've got VS Code. I will say I have GitHub Copilot currently. I think I'm going to leave it on. If it gets too annoying, I'll turn it off. But it's kind of interesting to see what Copilot thinks we should be doing sometimes. So if you see some gray text populate, that's where it's coming from. So you can see here, we've got our contracts, we've got our tests, and we've got our config. So the first thing we want to do is take a look at our test, right? That's where things start. This test is really, really basic. So what this is doing is it's just checking to see if our actual contract is deployed. That's it. All it's doing is to look and see, is it deployed? Also, this name is wrong. We should probably change this to hello. So let's go ahead and change all of these to just hello. That'll make things a little simpler. So let's run this. How do we test in Truffle? Well, we just tell Truffle to test. And that's it. Now, you're going to see this is not going to work because our contract isn't deployed. It even tells you, hello, has not been deployed to detected network. So what do we need to do to get it to deploy? If you look at migrations, you'll remember I mentioned that migrations is Truffle for deployments. In here, we have an initial migration, and it deploys the migrations contract, which we can see over here. But we don't have anything to deploy our hello contract yet. So how do we do that? Let's go ahead and make a new file. We'll call it to hello deploy. And in here, we'll need to import or require our contract, the hello contract. So const hello contract equals and artifacts dot require. Look at that. That's GitHub Copilot coming in pretty handy. It's not hello contract though. It's just hello. And spelling is important. So this will create a variable hello contract that has our hello contract in it. From here, we will need to deploy it. So again, GitHub Copilot, man, is doing work. So we'll need to export a function, call it deployer, and all we need to do is deploy our contract. So that's it. All right. So this should deploy our contract now. So let's go back to our test and see what happens. We'll rerun our test. Boom, green check mark. It makes me so happy when we see the green check marks. So we got our first passing test. That's right. We are officially doing test-driven development. All right, so we have a contract that we could, in theory, deploy. We haven't actually looked at our contract yet, though, have we? What does it do? It basically creates itself, and that's it. All it does is create itself. And it'll even tell us that we don't need this constructor because we're not doing anything. So what do we need to do from here? Well, test-driven development. Let's go back to our tests. All right, so what do we want it to return? The first thing that we need to do is describe a new function. I'm going to call it greet because it's going to greet us. And we're going to need to describe what it does, right? So first thing we need is describe a function called greet. And then we also need to describe what it's actually going to return, right? So it should return hello world. Man, GitHub Copilot is amazing and also terrifying. So the first thing we need to do is describe the function, right? So describe, and we called it greet. I guess we'll call it greet. We haven't called it anything yet. And it will describe what it actually, tell it what it returns here. So it should return hello world. Look at that. You put in comments, GitHub Copilot knows what's up. And here again, we're going to set a const of hello, and we're going to await and make sure it's deployed, right? So let's go ahead and, I think that looks good, Copilot. Then we will get the result from our greet function and assert that it's equal to hello world. Again, all of this looks just about perfect, right? I think I might tweak it just a little bit, but this is an awesome, awesome starting point. One thing to note, we're going to need to close out that parentheses. GitHub Copilot doesn't always do everything exactly right. So we've got a result. I also like to throw in a expected and then ensure that result is equal to expected. And we'll throw in a little comment in here too and say that we were greeted with hello world. Right? Everything looks good so far, yeah? Awesome. Let's test it out. Let's see the sad lack of a green check mark. There it is, failing. Okay, so check this out. Hello.greet is not a function. So it's not even telling us that we didn't return the right value, but it's telling us we haven't actually defined a function called greet within our contract. Let's go do that. Inside of here, we have our contract. And inside of our contract, we don't need a constructor for this one. But what we do need is we need a function called greet. And this function, we need it to be available outside of the contract. So we're going to say it's external. And it's only going to be a view. What that means is it's just going to look at stuff. It's not actually calculating anything, not doing any changes. So it's basically saying it's going to read. So it's a view, and it's going to return a string, all right? From here, we could just hard-code it at this point to return hello world. So let's check that out. Return hello world, right? This is it. This is it. We're living the dream. All right, what's it saying here? Data location must be memory or call data. So I forgot to do one thing here. We want this to just be a memory. We don't want to return anything to the actual blockchain. So it's also telling us right now that it could be pure, not just view, but we can ignore that for right now because we're going to change things up here in just a second. So one thing to remember, save. Let's go check it out now. So we've created the function greet and we have it returning hello world. Sweet. We've done it. We've written a smart contract. It's not the world's most interesting smart contract, but we've got a smart contract that's working and returning hello world. At this point, we could deploy this and call it, and life is great. But I think that we should go a little bit further because this is a good starting point, but I'd like to interact with it just a little bit, and that'll teach us a few more things. One thing that I'd like to be able to do is I'd like to be able to change who we say hello to. Maybe we don't want to say hello to the entire world, right? So we want to change it so that we can have someone to greet. Probably not the right term for it. In my brain, I'm thinking we want to change the greetee. You have the greeter and the greetee. Maybe that's the wrong word for it. I don't know. I might be making things up here. But I would like to be able to change that. Now, another thing to keep in mind, anytime that we're dealing with the blockchain, it's public. If we create a function to change a term that our greet function calls, and we don't say only certain people can change this, that means anybody could change it as long as they paid the gas fee. We don't want that. So what we need to do is we need to talk about ownership. So let's just take a couple notes real quick. So we want to create a function that allows us to change the greetee. And we also want to ensure the function, boom, yeah, is only called by the owner. That's right, GitHub. That's right. So how do we do that? We could, within our contract here, create our own owner function, right? But we don't want to do that yet. What we want to do is there is a set of contracts that have been vetted. They're definitely like bulletproof, created by a group called Open Zeppelin. And it's really cool. You just npm install them. Now, Open Zeppelin contracts are interesting to think about in this instance, because if I do this, if I just npm install them, it's going to look like it worked, but they're not here. So one thing to keep in mind is when you truffle init, it doesn't create a package.json. It doesn't do any of the regular npm stuff. And so we need to npm init this directory. And because we're not actually creating an npm package, I just go ahead and go with the defaults. But at this point, you'll see it created our package.json. And now if we install Open Zeppelin contracts, you'll see we have a node modules file. And I would never recommend this normally, but there's not much in there right now. So we can kind of take a peek and see this has installed a bunch of different contracts. One of them in here is called Ownable. And let's take a look at it real quick. Let's go back to VS Code and dig into our node modules. From here, we'll take a look at access ownable. And you can see this is a contract. It's very similar to what we just did, but way more detailed. And what this does is it enables us to see who the owner is, assign things to be only doable by the owner, which that's what we're going to need. You can also transfer ownership. You can set an owner. There's lots of things that you can do in here. And while we don't need all of these different contracts, this is a great like tool suite of contracts to start from. And you know that there's not like a mistake in here, just something silly that will be detrimental in the long run. It's important because anytime that you deploy your contract to the Ethereum blockchain, you can't undeploy it. It's like a write only. We only go forward in time on the blockchain. So keep that in mind as you're thinking about contracts, is that like, if you make a mistake, if you introduce a bug and you don't have a way to fix it, that contract is going to be done unless you can find some way to fix it, or you have to move everybody over to a different contract. So that's why it's very important to ensure that you have vetted contracts, that you have somebody else look over your work before you submit an actual contract. All right. So we have the Open Zeppelin contracts. Let's go to our test suite and let's talk about making another test, right? So the first thing that we need to do is we need to think we're going to be using accounts, right? Because we want to make sure only the owner's account can do certain actions. If you check it out, when we initialized this test via Truffle, it says uncommon accounts to access the test accounts made available by the Ethereum client. That's what we need to do. They've got it right here. All we have to do is delete these, and accounts will now be available for us. Accounts is a array. There's a bunch of different accounts in here. 0 is going to be the one that is deploying everything for us by default. What are we testing? We're going to ensure the function can be called by the owner, right? Okay, so how do we do that? Well, we already are inside the greet function, right? But we need to be outside of that to check for the owner. So let's go ahead and move this up here. And then we don't want to describe greet. What we want to describe is owner. That's the function to check ownership. Owner, we want to check first that we can get the address of the current owner, right? So this is basically GitHub Copilot, man. It's doing work. It should return the owner. We have our actual contract being deployed, which we will need to deploy it again. And then we get the owner, right? Result, await for owner. Expected, we expect the owner to be the same person who deployed it. So first, this is kind of doing two tests at once. It's ensuring that we can get the owner, and it's also ensuring that the owner is the right person. I think that we want to just check first that we can get the owner. So I'll go ahead and take most of this, but I'm going to get rid of this line because we don't need that. And we don't necessarily need to say equal. We just want to assert that we get a result back. And we're just going to say that that's the current owner, right? So, all right. So this will test and ensure that we're getting back the owner just by itself. So let's check it out. Sadly, I think we're going to have some red again. So we're going to truffle test. Yep. Oh, no function, right? Okay. So we downloaded, installed the Open Zeppelin contracts, right? Now we need to use them. So Solidity is very similar to JavaScript. We're going to import Open Zeppelin contracts, and we're not going to do an ERC20 token. We're not making NFTs today, GitHub. We want to go to access, ownership, and ownable. Sweet. Except this is the wrong path. Open Zeppelin, access, ownable. There's no ownership directory. Silly GitHub. Okay, cool. So we import all the contracts that are within ownable. The key piece is we're going to say our contract. It's amazing. It's ownable. That's it. So we didn't implement a owner function, did we? No, we didn't. Okay. We've run into another problem here. So you'll notice that it's complaining about the versions, and it's saying the compiler is not the same version as what it's asking for here. If you notice in our contract, we're saying that we want basically any version of Solidity to compile this. But if we go and look at ownable, you'll notice that it is pegged to 0.8, and we need to fix that. So how do we fix this? Well, we got to go into our truffle config. This is where we pick which version of the compiler we're actually using. And if you look here, you can see that this line right here tells you which version of the compiler to use. If we uncomment this, and I believe that 8.7 is the current version within the 8 range. So let's see here. If I change it to 8.7, give it a save, come back here, run our test again. And we have 3 passing tests. Fantastic. Again, you'll notice there's a warning saying that we can give it to peer. This is the same warning that we see here. So it's great to see that the test suite is actually giving us those warnings as well. All right. So we can test and get back the fact that we actually have an owner. Now we need to ensure that our owner is the correct owner, right? So I guess I should change this because this is not true. Ensure the function can only be okay, and then let's see. It can return the owner. And then we also need to check and make sure it returns the owner's address, right? So again, we uncommented accounts. Make sure that you remember to do that. It's important. So it should return the owner's address. Sounds good to me. So we're going to get and make sure that it's deployed. And then we're going to get our result, which is the owner. And GitHub Copilot did not do the expected. I just like to do that. I don't know. I think it's nice to know why that's there. And I don't know, maybe just a little bit more here. Matches the owner's address, right? So this is basically saying we're going to deploy the contract. We're going to get the owner, and we want the owner to be the first account in our accounts array and make sure they match. Cool. Give it a save. Let's go test it out. Boom. It's passing again. I will say, it kind of feels like we're not doing test-driven development because we didn't do any development to pass that test. But we cheated because we used the Open Zeppelin contracts, which already have the ability to return the owner. And this is why we didn't need to do much other than add the fact that our contract is ownable using those contracts. All right, so we have a contract that will enable us to say hello world, right? And we wanted to be able to change world. So we're going to have to do some work here. Let's check it out. The first thing that we need to do is we got to split up this string, right? I still want to say hello. I want to be friendly, but I don't necessarily want to say world. So to me, it sounds like we're going to need to create a string. And this string does not need to be public. It can be private because we're only using it within our contract. Now, it will return a string that is public, right? So this one's going to be private. And I like to put a little underscore. I think it's pretty common practice to put an underscore in front of internal variables. We'll call this greeting. And we're going to say hello, comma space. And then I mentioned this really weird word earlier, greetie, the one who's going to be greeted. And we'll have that be world for now, right? So we'll start it with world. And then we need to take those two strings and combine them. So this is where things get a little different in Solidity than JavaScript, right? Because I think a lot of people would think I can just do this and life is good, except it's not, because you can't do this. So what we need to do is we need to take these two strings and we need to pack them together. Okay, so in Solidity, that looks like this. We're going to do ABI dot encode packed. And this will take these two values and it will put them together into one encoded what? A string. So we're going to tell it that we need it to be a string. At this point, we've taken our two strings, we've packed them together, and now we're returning them as a string. So I think we should be good. We've done some minor refactoring. The nice thing about having tests, we can go test it. We run our test suite, and we see all green check marks. Feels good. All right, so we're still basically in the same spot. We've just made things way more complex. But now we need to change the greetie. Okay, so we've got our notes here where we want to be able to change greetie, right, to be whatever we want. So how do we do that? We need to create a function, right? But before we do this, what do we need to do? Add a test for it. That's right. So we're going to add another test here. So what does our test need to do? Our test needs to update the greeting message. Sure. So we need to set the greetie, right? I guess we can be a little more explicit here. Well, no, that's fine. That's fine. So let's describe set greetie, right? And this function, what we're going to need to do is we're going to need to deploy. And then we're going to need to set expected, right? Call set greetie with a value. So we'll set our greetie. Call greetie, set greetie, right? And then check the greeting. So we'll need to get actual. So the actual value returned from the greeting, and then do our assert, right? Let's start here and get this thing deployed. So the first thing we need to do, similar to above, is we will deploy the contract, right? And then we're going to set expected. So here we don't expect it to be hello world anymore, right? What do we want to say? Since it's a robot talking to us, I like just saying hello human. You know, it's a friendly robot. That means that greetie is going to be human. We need to make sure we put our exclamation point in there. Otherwise, our test will not match. Once we've done that, then we're going to go ahead and set the greetie, right? So we will call wait because it's an asynchronous function. We'll set our greetie, and then we're going to call greet to see what the actual value is that we're returning from the contract now, right? So we've updated it, and now we're going to check it, and then we're going to assert equal the actual and expected, and assert that we are greeted with hello human. Cool. So let's give this a try. Again, sad panda, it's not going to work because we don't have that function there yet. Oh, I made a mistake. Async functions don't work unless you tell them that it's an asynchronous thing that you're doing. We'll need to right in here, and I forgot my it. Oof, brutal. So we need to set the greeting to past in string, and this is async. And all of this will go down here. I think my brackets are right now. Got to remember those its. Cool. So set greetie is not a function. Back to our contract here. So here we need a new function called set greetie, right? And it wants to take in a string, which we do, but this is one of the times when Copilot's not right. Where we want to get this from is from the call data. So call data is what's passed in, right? And so we'll get that, and we want it to be, we're going to call it new greedy. And we want this to be external, which means that we can call it outside of here. And this is the key piece. We only want the owner to be able to call this function, right? So whoever deployed this contract is the owner. Again, if you remember when we looked at ownable, there was the ability to transfer ownership. So that's something to keep in mind. But we only want the owner of this contract to be able to call it. And basically, all we need to do is we have a variable, greedy, that we're using here. We just need to update it to whatever we sent in our call data. So we're going to set greedy to be new greedy, and we're done. That's it. Run our tests again, and make sure you saved. I can't tell you how many times I forget to save, and I'm like, why is this not working? So we've saved it, we've run our tests, and boom, settings that get passed in, get updated. It returns a new greeting. That's awesome. At this point, the only other test that we could do would be to ensure that only the owner can call this. I'm not too worried about that test right now, though, because I trust OpenZeppelin. If you wanted to do that, you could go ahead and assert the ownership in a test and try calling it with accounts 1 and see if it worked. I'm pretty sure it wouldn't, but we're good. So now, what do we do with this? We've created it. It's just sitting here, and every time we're running truffle test, it's not doing much of anything other than compiling it and running it, right? We mentioned Ganache, and we're going to set up a new workspace. It's looking for our truffle config. So we need to do a couple of things in our truffle config to get it ready to go for Ganache. One thing I'm going to point out real quick, and I don't know if this is just the version that I have or whatnot. When we look at our truffle config, it has all these like pre-done things in here. This is what we want, right? We're doing local development, and so our network is going to be development. There's some other stuff for other networks you can actually deploy to various test Ethereum networks. They cost Ethereum, but you can find a faucet which drips, quote unquote, Ethereum, and it will give you like fun money to play with, basically. Robston's one of them, and it's not real Ethereum, and so you can test with it, and people give it away for free. It's hard to find those faucets, but we're just doing it locally. One thing to note, this port is not the same in Ganache. I don't know why this is. So when you go to Ganache and you look at the server, you'll see this port number. It needs to match. It's off by 1,000, and I don't know why. It took me a long time, the first time I was doing this, to figure out that the ports were wrong. So make sure that you change this port number to match whatever port you're using for development. Okay? So we're going to save it here, and we're going to come into Workspace, and we're going to add a project, and then we're going to pick our truffle config, open it, and save our workspace. And that will actually create a local version of the Ethereum blockchain that we can test against. Now, one thing to know about Ethereum is this mnemonic, this seed phrase, in general, would be extremely sensitive. You do not want to put this anywhere. You don't want anybody to know about this thing. You want to keep it under lock and key. This is just one that's made up for testing with, so that's why I feel okay sharing it out there, because if you want my 100 fake ETH, you're welcome to have it. You can fire up Ganache and do the same thing. Again, here you'll see these accounts. You'll see index 0, 1, 2, 3. These are what will be referenced by that accounts 0 that we referenced earlier. So when we deploy this contract in a moment, it's going to cost us Ethereum from this balance right here on index 0 of our accounts. So deploying the contract, right? Let's go ahead and do that. How do we do that? Remember, truffle, deploy, and migrate are the same word. They mean the same thing. So we do truffle migrate. You'll see it compiles the contracts. Looks similar to testing. Aha, but then there's something new here. check it out. It runs the migrations, and there is hello, deploying hello. It actually deployed our contract to the blockchain that we're running locally. You'll see it did cost us some money. If you go back to Ganache, we have less ETH than we did a moment ago. You can check it out here. We have the actual contract creation happening here, right? Like this is the contract all encoded. You can see our contract name down here. If we check out the actual contracts, you can see we have hello right here. It's deployed. Sweet. So at this point, our contract is deployed and we can interact with it. But we need to create a front end to do that unless you want to do everything from the command line. So how do we do that? That's where Svelte comes in. So let's go check out Svelte. All right, so Svelte is what we're going to use for the front end. Now, I mentioned earlier that we're going to be using an NPM package called Svelte Web 3. So let's go ahead and set these up. And this is where, for this project, I don't know if this is the proper way to do things, but we're going to put Svelte inside the directory we already have. So one thing, if you come here to svelte.dev, it'll give you kind of a how to start. And this creates a little tiny sample project. So let's go ahead and fire that up. In order to do that, we'll need to use npx, dgit, the template, and then instead of my Svelte project, we're going to do something a little bit different. So let's go back to our terminal. And here, we're going to take that, and then we're going to install it into a Svelte directory here. And what this will do is it'll take the template and clone it into the Svelte directory, but without any of the history. So it's basically like creating an initial commit for us inside that Svelte directory. If we look at the instructions, it says that we need to go into the directory that we created and then run install and then run dev. So let's do that. Before we run dev, though, we want to install the Svelte Web 3 NPM package as well. So let's go take a look at that package. All right, so all we need to do is install Svelte Web 3. And then this is something that's weird. This script is how we're going to actually inject it so that we can use this library within the HTML. So we'll install it, and then we'll put this into our index.html. So first we install it. And if you take a look at your VS Code now, you should see, let's clean up this a little bit here. There's a Svelte directory. Inside there, we have our basic Svelte application. This is going to be the meat and potatoes of our actual application. So let's close everything else just to keep things nice and tidy. We're done with the contract. Now we're going to focus on just the front end. Inside public, you'll notice index.html. Let's go ahead and add that script tag here as well. Cool. And now npm run dev. This will kick off the actual Svelte instance. And you'll notice this normally would say 5,000. I have this other version of our application running. That's why it doesn't say 5,000. So we'll go ahead and just use this crazy port for now, just to keep things easy. And hello world, that's our application, right? No, this is not our application. This is just the regular Svelte application saying hello to us because that's what it does. All right, so we need to do a few things. First of all, we need to get Svelte to connect to our wallet. And we also need Svelte to be aware of the contract. This is something that's kind of interesting. We need the JSON for the contract in order to interact with it. So what we need to do is we need to update Truffle and let it know where to build the contracts. So let's take a look at our Truffle config real quick. If we look in here, we should be able to add a build directory. And we want to put it inside Svelte source contracts. So that'll put it in here in Svelte inside our source directory, and it'll make a subdirectory called contracts. So anytime that we do our migration from Truffle, it will update what's in this directory. Now, what it's going to put here is a JSON file that then we can use web3.js to access, and that will give us the ability to interact with that contract. So let's go ahead and run our migration again just to get this populated. So we'll stop our web server. We come here. We run our migrate again. You'll see here, it's going to deploy again. And now when we look, we see contracts, and you'll see these JSON files. What these do is they tell that web3.js is able to interact with these and see what's available, what we can use, all these different things. It has the actual bytecode that will be deployed. And this is how we'll deal with our contract using Web3. All right, going back to app.svelte. The first thing that we need to do is we need to connect to our wallet, right? So if we look now, and speaking of wallet, let's go ahead and set this bad boy up. So we need to set up our wallet to use localhost. You can pick here different ones. So Ethereum mainnet, this is like real Ethereum when you're going to spend real money in the real world. There's a bunch of different test networks available. There's also a local, and you want to make sure, again, that the port is correct, that 8545. So we connect to local, and we're going to import it using our secret recovery phase. So that is going to be here under accounts. You'll see this mnemonic. If you just copy that, come back to MetaMask, put that in here, and then you'll need to set a password. Again, you don't have to worry about this being super secure right now. This is only for the test account. You'll see that your Ethereum balance should match what you have here. And your account, 6C26, and it ends in 3893. So this address, this wallet address, is what we now have in our MetaMask wallet. So if we check that out, we can see this says not connected. We need to fix that. We need Svelte to talk to MetaMask in order to interact with the blockchain. So let's fix it. The first thing I think we should do is go ahead and just clean this up, right? We don't need any of this, and we don't need name for now. What we do need is a function to connect to our wallet. So let's go ahead and create that. So we'll create a function called connect wallet. And what that's going to do is it's going to see if we can see an Ethereum wallet first, right? So if window, so we're going to look at the window and see if Ethereum is available. If it is, then we can look for Web3. And using Web3, this is imported from that script tag that we added to index.html. We're going to add Web3 to our window object. We're going to await it. And we're going to enable the Ethereum piece of the window. What this is, this will be MetaMask, right? So it's checking to see, do we have something available to connect to Ethereum? In this case, it's going to be MetaMask. And then we're going to go ahead and set a variable called MetaMask connected. And we're going to check and see if we actually did connect. So if we're actually connected, we'll update this variable to be true. Spelling is important. So this is to connect our wallet, right? We used as variable MetaMask. Let's go ahead and make it reactive so that we can use that later to change things on our page. The little dollar colon is a little bit of syntactic sugar for Svelte that enables this value, this variable, to refresh things on our page if it changes. So basically they'll watch it, and if the value of this variable changes, the page will respond accordingly. So this is going to be based on the Ethereum being connected by default. So we use a little ternary operator and see if it's connected. If it is, true. If not, false. And spelling, again, is important. Thanks for graying out, so I knew something was up. We also need to return connect wallet as a promise, right? So let's go ahead and do that. That way we can wait for it to load and refresh the page accordingly. And I found that it works really well to make this reactive as well. And we need one more function, but we'll get to that in a second. So these are grayed out because we're not actually using them yet. So inside our main tag, I saved, and it styled this beautifully for me in a way I didn't want it to. So in here, right, we want to put in an if statement. And again, this is the Svelte if, so it's really, really slick. So basically, if we can have Ethereum in our window, then what we want to do is we want to say that we are already connected, right? Because if we already have Ethereum available to our window object, we're good to go. So we'll just say something like browser wallet is already connected to MetaMask. And just to make sure, we'll go ahead and use that variable that we used up there, MetaMask connected, right? So the curly brackets let Svelte know that that is a variable. And I think that's all that we want this one to do. This is just to like check and make sure life is good. Now, if we have Ethereum and MetaMask is not connected, right? That's when we want to connect to MetaMask. It should prompt us when we come onto this page. It should prompt us to connect already, but just in case it doesn't, we'll give this a go. So if window.ethereum, again, this is saying that like we have Ethereum available and MetaMask is not connected, right? Then we want to do something like maybe show a button. And on click, we want to click connect wallet. This is that function I mentioned earlier that we'll need to build. And let's see, we'll go ahead and say connect wallet, right? So now we've got that. And if we're good, we can say else. And here we've got something like, you know, wallet connected. Sweet. And let's go ahead and close our if statements. Give it a little save. Uh-oh, we got a problem because this is not defined. So let's go ahead and add one more function up here. Function on click connect wallet doesn't take anything in, and here we'll just go ahead and say we want to return our promise of connect wallet, right? I think everything looks good here. We're not using promise yet, but I think it'll be okay. So let's see. We've done a few things. We have not started our server. Let's go ahead and run dev. We got that crazy port number. For you, it'll probably be 5,000. And normally this would hot refresh, but since I stopped the server, I'm going to give it a refresh. Oh no. Crazy port number doesn't match. I'm surprised it changed it. Hey, check it out. MetaMask is here, and while I haven't picked an account, it's telling me my wallet's connected. It's because we already got there. We just were picking the account. You'll see now, connected. If we go ahead and disconnect this account, you'll see here it's false now. If I cancel this, right, it's false. We've got our connect wallet. Go ahead and click connect, pick your account, connect, boom, wallet connected. So we've got MetaMask connecting to our Svelte application. Awesome. What's next? We need to show our greeting, right? So I think probably the best way to do this is to create a new component. New file. Let's just go ahead and call it hello.svelte. In here, we're going to need to import Web3, and we're also going to need to import that JSON file. Something interesting is going to happen when we try to import that JSON file. So first, import Web3 from Svelte Web3. And we also want to import greeter contract. Oh, it's not greeter contract. What am I talking about? Hello contracts from /contracts/ hello.json. Right? So we need those two items. And then we're going to need to get the value back from the greeter. This is going to take some doing. So we're going to need to make a function. We'll call it get greeting, I guess. That seems good to me. So here we're going to need to use Web3, right? And we're going to use the window.ethereum. We're going to need to get our network ID. That tells us like where we're deploying to. In this case, it's going to be our local test network. So let's go ahead and do that. So const network ID, boom, await Web3, network ID, seems good. We're going to need to get the deployed contract. So here we kind of know what our contract is. It's the hello contract, and we know it's going to be on the network that we're using. So let's go ahead and do that. So const deployed network. Man, GitHub Copilot coming in clutch. So hello contract, that's the one that we're importing from our hello JSON. This tells us everything about the contract, right? This is what lets Web3 do its thing. What network is it deployed to? It's going to be on the network that we're using based upon our Ethereum wallet. So if we go back to Firefox, you'll see here we have our networks. So it's going to be based on this local host, which is pointing to Ganache. All right. We have our deployed network. We have our contract. It's coming in. So what is next? Next, we'll need to actually get the contract, right? So const contract equals, and it's going to be a new Web3 contract. The ABI is going to be the information from that JSON file that we'll need. We'll also need the deployed network and the network address. Once we have those things, then we can actually call methods on the contract, right? Man, GitHub Copilot is just doing work. You almost got it perfect. I'd like to make this an await. So we'll say const response equals await, and we'll call the greet method. If you remember, let's take a peek at our contract real quick. The greet method is the one that says hello, and then whatever we said the greetie was. So we'll call that, and then we just need to return our response. Sweet. Again, we're going to return a promise here. We're going to make this a promise, I guess. And then we need to actually do something with it, right? We've got all this stuff happening. We haven't done anything. What's awesome about Svelte is some of this built-in stuff, man. This await then. Whew, it is sweet. So we're going to await the promise, and then we're going to have our greeting. So here, we'll just say something like loading Given that this is local, I don't know that we'll ever actually see that, but we need it. And once we're done, let's just make this nice and big. We'll say greeting. Okay, here we go. Moment of truth. It didn't refresh. When I refresh, I see nothing. That's not good. Remember I said there was going to be something weird with that JSON? If we stop this and restart it, it doesn't tell us anything. What is going on? Did we get we got a new port. Came here, next, connect. Oh, it's going to have to connect every time. I am going to stop that other process from running. All right, we're back. I've killed the process that was hogging up port 5000, so things should be a little bit better. If we run this, we'll see now we're on port 5000. Fantastic. This will make things easier. Okay, so we connect our wallet. Life is good, except we don't see anything. So two things. One, I made this component. Did I ever use it? No, I did not. So we need to import hello from haha, silly computer. It's not hello.view, it's hello.svelte. And then if we have this and MetaMask is connected, I don't think we need to say wallet connected. We can just go ahead and use hello. Right? Seems good to me. Let's take a look, and nothing changed. It still says wallet connected. I saved it. Why does it still say wallet connected? Let's go look here. Everything seems good. There's no errors. What happens if I start it again? Aha. This is the problem. So I mentioned that using JSON, we'd have to do something. Basically, Rollup doesn't know how to deal with JSON from the get-go. You just need to tell it what to do about the JSON. So what we'll need to do is we'll need to install the plugin for JSON. So this plugin right here. So npm install. Yeah, npm install. And then we will also need to import it into our rollup config and tell it to use it. So if we come here, inside of our Svelte directory, you'll see a rollup config. In here, we'll need to import it. So we'll need to import it here, and then I think we just need to add it somewhere in our plugins here. I don't know, after CommonJS seems to feel like a good place to me. Add it there, come back here, give it a restart, and no error messages. It's complaining about our CSS being unused. That's okay. Let's go check out the actual page. Again, didn't refresh because we have to refresh manually once just to get it going on the hot reload, but you'll see hello world. Sick. It's working. We're reading from the blockchain right here. Life is sweet. We need to be able to set our greeting to have a new greetie. And then we're done. How are we going to do it? Let's come back in here. We're going to go back into hello. So this piece, we need to add something, a little script where we can update the greeting, right? We're going to need an input, and it's not going to be super slick, but it's going to work. So the first thing, let's go ahead and just add our input. Input, and we're going to bind this value to a value equals, we'll call it greetie. Again, I don't know if this is a real word, but it works for me. And then we want to probably just make a button that says on click. And we're going to call a function that we're going to make called set greetie. We're going to pass in greetie. And let's just say submit. Seems good. So it's giving us a little bit of grief because we don't have a greetie. So let's go ahead and declare a greetie. So let's greetie. And I like just, having it be human for now. We'll be able to change it to whatever we want using our input down below. And now we need to make another function. And remember, it's going to take in the greetie. And we'll need to, get web3. It looks basically like what we have right above. One thing we will need to do before we get the network ID is we need to get the accounts. Because if you remember, when we wrote our contract, we have to only allow the owner to do it. So we need to know who is actually doing this. Get the deployed networks. And yeah, we've got our contract, right? This GitHub Copilot is just, it is smoking. I dig it. And then we also need to, set the greetie to greetie, and we'll send it. And from accounts, whoops. Oh no, come back. From accounts. So this is saying who's sending it, and it's accounts 0. Remember, we had a couple accounts that we could pick from in our wallet. This is going to be the first one. It's also, because we logged in with the same credentials that created the account, going to be the account that created the value. And I think we need to go ahead and update our promise once we're done, right? Because we've changed the greeting. So this way we'll reflect the new greeting. So let's take a look. Boom. Look at that. Already there. It's so fast. And if we click submit now, oh, snap. It's working. It's going to cost us some fake money. And if we say confirm, ho ho. Great success. Did it work? Oh, it's beautiful. So we can also go take a quick look at Ganache, and you should see here in the transactions, look at this, contract calls all over the place. Hello, hello. If you check out the first one, you're going to see it's changing it to human. If we go back and check out the second one, success. That's right. So we've done it. We have created a smart contract. We've created tests. We've done the whole test-driven development thing. We did it. We created a contract. It employs the Open Zeppelin contracts for best practices. It's only usable, modifiable by the owner. We've deployed it to Ganache on our local machine. We've then connected Svelte to that local version of the Ethereum blockchain. We've gotten the contract results. We've sent an update to the contract. Man, life is good. We're doing awesome. So I hope that gets you started on the journey for distributed application development. It gives you just kind of a quick little dip in the water that is Solidity, Ethereum, Svelte. A lot of people are going to be using React to do the same stuff. I just like Svelte. I think it's cool. So I decided to make this little thing. If it was helpful, I don't know, do all the things, smash the like button, subscribe. I don't know what content's going to look like. I hadn't seen a tutorial like this. I thought I'd make one. Hopefully it was helpful. Stay awesome.